In the spring of 1961, in a shallow excavation trench carved into the red clay soil of a Neolithic settlement in central Romania, archaeologist Nicolae Vlasa made a discovery that would quietly unsettle one of the most fundamental assumptions in the history of human civilization. Buried beneath the remains of a dwelling near the village of Tartaria, sealed within a ceramic vessel alongside burned human bones and 24 ritual objects, he found 3 small clay tablets. The largest measured no more than 6 centimeters across, but the symbols pressed into their surfaces told a story that conventional archaeology has struggled to reconcile with its accepted chronological framework for more than 6 decades. Carbon-14 dating of the organic material found within the same sealed deposit placed the assemblage at approximately 5300 BC, more than 2,000 years before the earliest securely dated writing at Uruk in Mesopotamia. Yet the symbols inscribed on those tablets bore structural similarities to proto-Cuneiform that specialists in ancient Near Eastern languages found immediately recognizable. Signs arranged in horizontal registers, grouped into what appeared to be distinct semantic categories, executed with a precision suggesting not primitive experimentation, but a scribble tradition already fully formed. What compounds the mystery is the burial context itself. The Tartaria tablets were not casually discarded or lost. They were deliberately sealed, placed within a ritual deposit alongside calcined human remains, perforated shells, and carved figurines of a type consistent with cult practice rather than domestic use. Someone made a decision to conceal this knowledge while simultaneously preserving it. The act of sealing was itself intentional and ceremonial. Tartaria was not an isolated case. Across 6 decades of fieldwork since Vlasa's discovery, archaeologists excavating sites from the Balkans to the Indus River to the Mediterranean coastline have uncovered inscribed objects in sealed context that predate the cities built above them. All of them carry scripts that modern computational analysis and linguistic scholarship have been unable to decipher. All of them suggest the transmission of a structured knowledge system from a source that conventional history has not yet identified. The investigation that follows draws on the work of archaeologists, linguists, archaeoastronomers, and computational scientists to examine what these sealed tablets reveal about the true origins of written language, the nature of the knowledge they encode, and why, after more than a century of serious scholarly effort, they remain silent. The evidence, as we will see, points toward conclusions that mainstream archaeology has been remarkably reluctant to embrace. The 3 clay tablets recovered from the sealed pit at Tartaria in 1961 represent the most precisely documented pre-Sumerian writing anomaly in the archaeological record. Vlasa's excavation report, submitted to the Cluj Museum of History and published in the journal Dacia the following year, documented every detail of the assemblage with methodical care. The pit, designated Feature 7 in the site record, measured approximately 60 centimeters in diameter and 40 centimeters in depth, and its contents were arranged in a configuration that Vlasa interpreted as consistent with votive burial rather than refuse disposal. The rectangular tablet carries a notation divided by a vertical incision into 2 columns, each containing a sequence of abstract signs. The circular perforated tablet bears a design divided into 4 quadrants with distinct symbolic content in each. The third tablet displays a horizontal sequence of marks whose formal parallels in proto-Cuneiform were independently identified by 3 separate scholars, including Adam Falkenstein and later Maria Gimbutas, working without prior knowledge of each other's conclusions. The problem is not that similar symbols appear in Romania and Mesopotamia. The problem is that the Romanian examples are demonstrably older by 2,000 years. The implications of that age gap did not fully surface until radiocarbon dating of the associated calcined bone material was conducted independently by two separate laboratories during the late 1960s, and again with more refined accelerator mass spectrometry techniques during the 1990s. Both rounds of testing returned dates clustering between 5,300 and 5,200 BC, results that placed the Tartaria assemblage firmly within the Vinca cultural horizon, and well before any securely dated inscription from Mesopotamia. Conventional archaeology had two choices. It could accept that a writing system or something structurally equivalent to one existed in southeastern Europe 2 millennia before the scribal administration of the Uruk temples, or it could dismiss the tablets as an intrusion, a later object that had somehow migrated downward into an earlier deposit. The intrusion argument was advanced seriously in the literature for several decades, most prominently by Marcos Merlini of the Prehistory Knowledge Project in Rome, but successive stratigraphic analyses of Vlas's original excavation notes and the soil profiles preserved in the Cluj Museum documentation have consistently failed to identify the disturbance channels, root penetrations, or rodent burrows that physical intrusion would require. What the sealed pit at Tartaria actually contains, when examined against the full body of comparative evidence, is not a curiosity, but a template. The practice of sealing inscribed objects within deliberately prepared votive deposits, separated from domestic refuse by both physical container and ritual intent, is precisely the pattern that archaeologists encounter at every site where pre-Sumerian or para-Sumerian symbol systems come to light. At the site of Gradesnica in northwestern Bulgaria, excavations conducted by Bogdan Nikolov in 1969 recovered a large ceramic vessel bearing incised symbols on its outer surface, sealed within a pit deposit dated to approximately 5000 BC. The Gradesnica vessel's symbols include a horizontal sequence of 9 distinct signs, arranged in what Nikolov's analysis, published in the Bulgarian journal Archaeologia in 1970, described as a structured register rather than a decorative border, a distinction with significant implications for how the marks were understood by the people who made them. At Karanovo in southern Bulgaria, another sealed deposit recovered during systematic excavations by Gorgy Georgiev between 1947 and 1957 contained inscribed ceramic fragments within a stratigraphic context, dating to approximately 5500 BC, predating even the Tartaria assemblage and carrying symbols formally similar enough to those at Tartaria that specialists including Harold Harman of the European Centre for Language Equality have argued they represent regional variants of a single coherent symbol tradition. The geographical distribution of this tradition resists any explanation centered on isolated local invention. Across a territory extending from the Danube basin in the west to the Black Sea coast in the east and south into the Aegean littoral, over 150 distinct archaeological sites have yielded objects bearing signs from the same formal corpus, maintaining consistent symbolic conventions over a period spanning more than 2,000 years, and a geographical range of over 800,000 square kilometers. No other early symbol system shows this combination of chronological depth and spatial breadth in the period before 3000 BC. The closest parallel is the token system of the ancient Near East, which Denise Schmant-Besserat documented across a similarly vast range, and whose relationship to the southeastern European symbol tradition represents one of the most pressing unsolved problems in the archaeology of early communication. What makes the Tartaria tablets the keystone of this investigation is not their age alone, but the deliberateness of their preservation. Someone made specific choices about what to seal within that pit. They chose objects bearing the most formally complex symbols in their symbolic repertoire, rather than simpler, more common marks. They combined these objects with burned human remains and ritual objects that carried ceremonial significance for their community, and they chose to place this assemblage at the base of a domestic structure, beneath the floor that daily life would walk across, as though embedding the knowledge in the physical foundation of inhabited space was both a preservation strategy and a statement of priority. The knowledge encoded in those tablets was not meant to be lost. It was meant to survive whatever came next. In 2009, computational linguist Rajesh Rao of the University of Washington published an analysis in the journal Science that generated immediate controversy within academic circles, not because its methods were flawed, but because its conclusions were deeply inconvenient. Applying mathematical entropy analysis to symbol sequences in the Indus Valley script, Rao demonstrated that the system's conditional entropy values fell precisely within the range characteristic of structured linguistic encoding, matching natural languages while differing significantly from both random symbol arrangements and simple decorative systems. When the same analytical method was applied independently by his teamed proto-Elamite to the Vinca symbols of southeastern Europe and to pre-Cuneiform token impressions from 4th millennium Mesopotamia, all three systems returned entropy values within a statistically narrow band of each other, suggesting they shared not merely surface similarities, but a common underlying organizational logic whose source has never been satisfactorily identified. This finding, which received only limited scholarly attention following its publication, carries implications for the question of script origins that conventional linguistics has not yet fully confronted. The entropy measure that Rao and his colleagues applied, known formally as conditional entropy, quantifies how predictable a given symbol is based on the symbol that precedes it in a sequence. A system with very high conditional entropy behaves like random noise, where knowing the previous symbol tells you nothing about the next one. A system with very low conditional entropy behaves like a rigid template, where each symbol position is almost entirely determined by its neighbours. Natural human languages cluster within a middle range that reflects the balance between structural grammatical constraints and the genuine informational freedom that makes language useful as a communication tool. The remarkable result that Rao's analysis produced was not simply that the Indus Valley script fell within this middle range, which would be consistent with ordinary linguistic encoding, but that proto-Elamite and the Vinca symbols fell within a range so close to the Indus results that statistical chance as an explanation requires straining credibility beyond reasonable limits. The systems were not merely language-like in isolation. They were language-like in the same specific way, suggesting shared underlying organizational principles rather than independent convergence on equivalent solutions. The response from specialists in the respective script traditions was instructive. Steve Farmer, Richard Sproat, and Michael Witzel, who had published an influential 2004 paper in the Electronic Journal of Vedic Studies, arguing that the Indus Valley script encoded no language at all, but merely political or religious symbols, challenged Rao's methodology on the grounds that non-linguistic symbol systems could theoretically produce entropy values in the linguistic range under certain conditions. Rao's rebuttal, published in the same journal later that year, demonstrated through comparative testing of known non-linguistic symbol systems, including road sign inventories, heraldic blazons, and DNA codon sequences, that none of these systems produced the specific conditional entropy profile characteristic of the Indus script and its structural parallels. The argument was not resolved but clarified. What Rao had measured was something real and distinctive about these undeciphered systems, even if the interpretation of that measurement remained contested. The mathematical approach pioneered by Rao's team was subsequently extended by researchers at the Santa Fe Institute, including Sitabra Sinha of the Institute of Mathematical Sciences in Chennai, who applied network analysis techniques to map the relationships between individual symbols within each undeciphered corpus. Network analysis treats each distinct symbol as a node, and each instance of two symbols appearing in adjacent positions within an inscription as a connection between those nodes, producing a map of the internal relational structure of the entire symbol system. When this analysis was applied to the Vinca corpus, using the complete published database assembled by Marco Merlini and Gheorghe Lazarovici in their 2008 compendium of Southeastern European prehistoric symbols, the network topology that emerged displayed properties that linguists associate with natural language lexicons, rather than with administrative notation systems or decorative repertoires. The same network topology appeared in the proto-Elamite corpus when analysed using the published database from the Cuneiform Digital Library Initiative at the University of California, Los Angeles, and again with somewhat less statistical clarity, but with the same fundamental structural characteristics in the pre-cuneiform token impression corpus documented by Schmant Besserat. 3 geographically separated, chronologically dispersed, institutionally distinct symbol systems, analysed by independent research teams using different but complementary mathematical methods, all pointing toward the same underlying organisational architecture. The probability that this convergence reflects independent local invention diminishes with every methodological angle from which it is examined. The critical question that these mathematical findings raise but cannot by themselves answer is what kind of information these systems were designed to encode. Rao's entropy analysis establishes that they were encoding something structured, something with internal grammar-like constraints. The network analysis establishes that their internal relationships mirror those of natural language vocabularies. But neither analysis reveals the semantic content, and it is precisely at the level of semantic content that all decipherment attempts have stalled. What remains is the structural fingerprint of a sophisticated information system spread across 3,000 years and 2 continents, legible in its architecture to modern mathematical analysis, but silent in its meaning. That silence is not merely an unsolved puzzle. It is, as the evidence accumulates, beginning to look like the product of a deliberate design. In the storerooms of the Louvre, the British Museum, the National Museum of Iran, and the Oriental Institute of Chicago lie over 5,000 clay tablets, inscribed with a writing system that has resisted decipherment for more than a century of sustained scholarly effort. Proto-Elamite emerged suddenly around 3100 BC across a geographical territory covering approximately 1 million square kilometers of the Iranian plateau, with tablets recovered from sites including Susa, Tepe Yahya, Tale Malyan, Godin Tepe, and Shari Sokhtar near the modern Afghan border. Its spatial distribution exceeds that of early Sumerian cuneiform by a substantial margin, implying a degree of administrative coordination across vast distances that conventional models of early state development struggle to explain. In 2012, Oxford University launched a crowdsourced decipherment project through its Cuneiform Digital Library initiative that enlisted thousands of participants worldwide. After several years of intensive collaborative analysis, the project returned no confirmed translation of a single proto-Elamite text, a result whose significance the academic community has been reluctant to acknowledge in proportion to what it implies about the nature of the system. The scale of the proto-Elamite distribution is worth pausing to consider carefully, because it has no close parallel among early writing systems and because conventional archaeological models have no fully adequate explanation for it. The site of Susa in modern southwestern Iran, excavated initially by Jacques de Morgan beginning in 1897, and subsequently by Roman Gierschmann and then Jean Perrot under the auspices of the Délégation archéologique française en Iran, produced the largest single assemblage of proto-Elamite tablets, numbering over 2,000 individual objects from stratified deposits dated between 3,100 and 2,900 BC. But the same script, with the same sign repertoire and the same numerical notation conventions, appeared at Shari Sokhtar in the Sistan Basin of eastern Iran, nearly 1,500 kilometers from Susa, at dates contemporary with the earliest Susa material. Between these two extreme points, proto-Elamite tablets appeared at Tepe Hissa near Damgan, at Tepe Sialk near Kashan, at Tepe Ozbeki near Tehran, and at over 30 other sites distributed across a range that spans the full breadth of the Iranian plateau, from its western Piedmont to its eastern desert margins. No other administrative writing system of comparable antiquity shows this degree of territorial reach in its earliest attested phase. Robert England of the Free University of Berlin, who has dedicated the greater part of his scholarly career to the proto-Elamite corpus, and who contributed the foundational sign list used by every subsequent researcher in the field, has characterized the system's sudden, wide distribution as evidence of a centrally organized institution capable of imposing standardized administrative practices across vast distances with a speed that should not have been possible for a society at the developmental level that the archaeological record otherwise suggests for the period. England's sign list, published progressively through the Cuneiform Digital Library Initiative database, contains approximately 1,000 distinct signs, a repertoire comparable in size to the early proto-cuneiform corpus from Uruk, but displaying a different internal organization that resists the phonological interpretation that eventually unlocked cuneiform. Most proto-Elamite signs represent commodities, quantities, and what appear to be institutional identifiers, but the system for combining these elements into complete notations follows rules that specialists have been unable to extract from 5,000 tablets, despite the application of every analytical method available to modern epigraphy. The Oxford crowdsourcing project, formerly titled Cuneiform Digital Library Bulletin and coordinated by Jacob Dahl of Oxford's Oriental Institute, established an online platform through which members of the public could assist in identifying recurring sign groupings and proposing phonetic values by analogy with known ancient Near Eastern scripts. The project's underlying logic was sound. Proto-Elamite shares some formal features with proto-cuneiform, and if loanwords or administrative conventions had passed between the two systems, a systematic comparison might reveal phonetic correspondences that individual scholars had missed. What the collective intelligence of thousands of participants produced instead was a definitive demonstration of the system's resistance to this approach. Sign groupings that appeared to show consistent combinatorial behavior in one subset of the corpus behaved differently in another subset. Numerical conventions that seemed stable within the Susa assemblage showed unexpected variation in the Shari Sokhtar material. The system refused to resolve into the kind of consistent phonological or logographic mapping that decipherment requires. After several years of operation, the project coordinators acknowledged in their published summary that proto-Elamite may encode information according to principles that have no close parallel in any other ancient writing system, a conclusion whose implications extend well beyond the boundaries of Iranian archaeology. The Vinca culture occupied an extensive territory across the Central Balkans, including modern-day Serbia, Romania, Bulgaria, and Macedonia, flourishing from approximately 5,700 to 4,500 BC. Archaeological excavations beginning with Miloje Vasic's pioneering work at the Vinca Belo Brdo site near Belgrade in the 1920s uncovered a civilization of unexpected sophistication, including two-story structures, standardized weights and measures, copper smelting evidence predating the accepted Bronze Age by over 2 millennia, and crucially, over 1,000 inscribed objects bearing a corpus of approximately 250 distinct symbols. The symbols appear on figurines, pottery, spindle whorls, and dedicated inscription tablets with a consistency of form across geographically separated sites that argues against random decoration. Archaeologist Shan Win's systematic analysis of the corpus, published in his 1981 study of pre-writing in southeastern Europe, demonstrated that the symbols appear in structured sequences and combinations that display the organizational properties of a coded information system, while stopping short of satisfying the criteria that would allow most scholars to call them writing. That distinction, as the evidence reveals, may say more about the limitations of our definitions than about the nature of the symbols themselves. Vasic's original excavations at Vinca Belo Brdo, conducted across a series of campaigns between 1911 and 1934, exposed a settlement mound 9 meters deep, whose stratified deposits contained material spanning over 1,200 years of continuous occupation. The sophistication of the material culture at every level consistently surprised the excavation team. Copper artifacts appeared in the earliest levels alongside clay, figurines of remarkable anatomical precision and pottery, decorated with geometric motifs of a complexity that demanded sustained aesthetic tradition rather than improvised invention. But it was the inscribed objects that proved most resistant to conventional interpretation. Vasic himself declined to classify the symbols as writing, describing them instead in his published reports as cult marks. But this designation was effectively a placeholder for the more difficult admission that their function was not understood. Subsequent analysis by archaeologist Alexander Marshak, whose work on prehistoric notation systems had established important precedents for recognizing structured symbol use in pre-literate contexts, identified in the Vinca corpus several types of structured sequences that bore formal resemblance to accounting notations rather than to the ritual marks or property stamps that conventional archaeology preferred as explanatory categories. The metallurgical context of the Vinca culture deserves particular attention because it directly undermines one of the standard arguments used to dismiss the symbols as pre-literate decoration. Copper smelting and casting at a level of technological complexity normally associated with the Bronze Age appears in Vinca sites, dating to approximately 5,500 BC, over 2,000 years before the conventional Bronze Age transition. B. Jovanovic of the Belgrade Archaeological Institute documented copper slag, ore processing equipment, and finished copper artifacts from the Vinca settlement at Pločnik in a 1982 report that pushed the earliest confirmed copper metallurgy in Europe back by a margin that required revision of textbooks across the field. A culture with the organizational capacity to develop and maintain complex metallurgical technology across a territory of several 100,000 square kilometers is not a culture whose consistent symbol system can be casually attributed to random scratching. The symbols and the metallurgy are products of the same social and intellectual infrastructure, and that infrastructure was substantially more complex than the conventional Neolithic developmental model allows. Harold Harman, whose comparative analysis of the Vinca symbols in his 2008 book Vega zum Menschen attempted the most systematic survey of their internal structure to that point, identified within the corpus a subset of approximately 45 signs that appear with disproportionate frequency at multiple geographically separated sites, and that maintain their formal characteristics with unusual rigidity across the entire temporal span of the culture's existence. These signs, which Harman designated the core repertoire, appear on objects from the earliest Vinca levels at Belo Burdo and the latest levels at Gomolava, with variations so minor that they would not prevent recognition as the same sign by any two independent observers. In a symbol system that develops organically within a single community over a few generations, this degree of formal stability across 1,200 years and several hundred kilometers is not expected. It is the hallmark of a codified, institutionally maintained scribal tradition, precisely the kind of tradition that the existence of a writing system would explain, and that the absence of one makes very difficult to account for. In the summer of 1993, Professor George Muziadis of the Aristotle University of Thessaloniki was directing excavation of a submerged Neolithic lake settlement near Kastoria in northern Greece, when a worker's trowel struck an object that would transform the debate about European prehistoric literacy. The object was a flat piece of wooden board, roughly 30 centimeters in length, covered in a systematic arrangement of incised linear marks. The preservation of the artifact, designated the Dispilio tablet in subsequent scholarship, had been made possible only by its millennia of submersion in anaerobic lake sediment that prevented decomposition. Carbon-14 dating of the wood returned a date of 5,260 BC, plus or minus 40 years, placing it among the earliest known inscribed objects in European prehistory. When the tablet was removed from its waterlogged context and exposed to air, deterioration began almost immediately, raising questions about the information lost before adequate photographic documentation was completed. What survived in the record is a sequence of marks that show consistent spacing, deliberate directionality, and formal variation of a kind associated with phonetic, rather than purely pictographic encoding, in a material and geographical context where no comparable inscription had previously been documented. The Dispilio settlement itself, designated Lake Orestiada in the formal site record, had been identified in the 1930s by local fishermen who occasionally dredged up worked wooden posts and fragments of ceramic material from the lake bed. Systematic investigation did not begin until Muziadis secured funding from the Greek Ministry of Culture in 1992, and the first season of underwater excavation revealed the outlines of a settlement of substantial complexity, whose full extent was not apparent from the lake surface. The preserved remains included wooden piles that had supported platform dwellings over the water, ceramic vessels of multiple functional types, stone and bone tools, and botanical material that allowed reconstruction of the agricultural practices supporting the community. The stratigraphy of the lake sediment surrounding the structural remains confirmed occupation dating from approximately 5,500 to 3,500 BC, providing a chronological framework against which the tablet's radiocarbon date could be confidently interpreted as representing the middle, rather than the earliest phase of the site's occupation. This means that the community that produced the tablet had been established and culturally coherent for at least several centuries before the inscription was made. The marks on the Dispilio tablet, as documented in the photographic archive assembled by Hormuziadis before deterioration, compromise the object's surface, display characteristics that epigraphers analysing the images have found difficult to explain within conventional Neolithic frameworks. The marks are arranged in a horizontal sequence with consistent spacing between individual units, a spacing pattern that resists interpretation as decorative, since decoration does not require uniform intervals between elements. The marks themselves show variation in both size and form that is inconsistent with the repetitive character of tally systems, but consistent with a repertoire of distinct signs used in structured combination. Comparative analysis by epigrapher Richard Janko of the University of Michigan, published in a 2001 paper examining the relationship between the Dispilio marks and the Vinca symbol corpus, identified 7 formal correspondences between Dispilio signs and signs from the Vinca repertoire documented at geographically distant sites, including Gradac in Serbia and Teodos in Romania, suggesting that the two traditions were not independent local developments, but expressions of a shared broader symbolic convention. The significance of the Dispilio tablet extends beyond its individual marks to encompass what it tells us about the material that has been permanently lost. Wood is among the most perishable of inscription media, surviving in anaerobic or arid conditions but destroyed by the atmospheric exposure that constitutes normal surface archaeological contexts. If a community at a Neolithic lake settlement in northern Greece was using wooden boards as inscription surfaces in the 6th millennium BC, the probability that this practice was both widespread and of considerable antiquity is high, and the probability that the surviving corpus of inscribed objects from this period represents a small and unrepresentative sample of the original total becomes correspondingly high. The sealed clay tablets at Tartaria and the incised ceramics of the Vinca culture may be the durable residue of a much larger inscription tradition conducted on organic materials that have left almost no trace, a tradition whose full extent and character we are only beginning to glimpse through the accidents of exceptional preservation that brought the Dispilio tablet to light. Every lake settlement, every waterlogged deposit, every anaerobic context in the geographical range of the southeastern European prehistoric cultures becomes a potential archive of inscribed material that conventional surface excavation would never have found, and the systematic investigation of these contexts has barely begun. When German archaeologist Klaus Schmidt began systematic excavation of Gobekli Tepe in southeastern Turkey in 1994, the site had been known to local villagers for decades as a source of worked stone used in building field walls and farmhouses. What Schmidt's team uncovered beneath the Neolithic mound, with the lowest layers yielding radiocarbon dates of approximately 9600 BC, would fundamentally challenge the relationship between symbolic representation and organized civilization. The T-shaped limestone pillars that dominate the enclosures at Gobekli Tepe carry not only detailed zoomorphic reliefs depicting specific animal species with anatomical precision, but also a recurring set of abstract symbols including H-shapes, C-shapes, crescents, and linear sequences that appear on multiple pillars across different enclosures. These symbols, documented in detail by epigrapher Joris Peters and Schmidt in their 2004 joint analysis, do not appear to serve decorative purposes, but instead follow spatial and sequential placement rules consistent with coded communication. They predate the agricultural revolution by at least 1,000 years, which means they predate the conventional model of complex social organization that supposedly made symbolic communication necessary in the first place. The physical scale of Gobekli Tepe demands attention before any analysis of its symbolic content can proceed, because scale is itself evidence of organizational capacity. The site covers an area of approximately 9 hectares and consists of at least 20 distinct circular enclosures, of which only a fraction have been excavated in the 3 decades since Schmidt's initial campaigns. The largest of the excavated enclosures, designated Enclosure D, measures approximately 30 meters in diameter and contains 2 central pillars reaching heights of 5.5 meters each, with estimated individual weights of between 10 and 20 tons. Quarrying marks on partially worked pillars still attached to the bedrock at a limestone outcrop, approximately 100 meters from the main site, demonstrate that extraction was performed using stone and flint tools, a technical reality that makes the precision of the finished carvings even more difficult to accommodate within conventional models of Neolithic capability. The anatomical accuracy of the animal reliefs on these pillars, encompassing detailed representations of foxes, boars, cranes, ducks, scorpions, and snakes, with musculature, scale patterns, and behavioral postures, rendered with what a trained naturalist would recognize as observational fidelity, required not only exceptional carving skill, but an intellectual tradition of systematic natural observation sustained over a sufficient period to develop and transmit that skill across generations. The abstract symbols are a different category of evidence entirely. The zoomorphic reliefs, whatever their precise meaning, represent a form of pictorial communication whose general logic is accessible even without knowledge of the specific cultural codes that govern their production. But the abstract symbols on the Gobekli Tepe pillars carry no pictorial referent visible to modern analysis, and their placement on the pillars follows rules that are regular enough to be identified as rules without being transparent enough to be read. The H symbol, which appears on multiple pillars across at least 3 separate enclosures, is always positioned on the broad face of the pillar shaft, rather than on the narrow edges, always at approximately the same height relative to the pillar's total length, and always in spatial relationship with specific zoomorphic motifs rather than with others. This is not the behavior of decorative ornament. Decoration fills available space according to aesthetic rather than structural logic. The H symbol's consistent spatial positioning within a defined relational grammar involving specific animal companions at specific pillar locations is the behavior of a sign operating within a coded system. Schmidt himself, in the years before his death in 2014, became increasingly direct about the symbolic character of these marks, stating in his 2010 monograph on the site that the abstract signs at Gobekli Tepe represented a proto-writing or para-writing tradition whose relationship to later Near Eastern script systems warranted serious investigation. The follow-up analysis conducted by Lee Clare of the German Archaeological Institute and Dietrich and Nottroff of the same institution, published in a 2017 collaborative volume on Gobekli Tepe's iconographic program, identified a total of 61 distinct abstract sign types distributed across the excavated enclosures, a number comparable to the sign repertoires of several known ancient writing systems in their early developmental stages. The signs show consistent execution across enclosures that were demonstrably constructed at different times, indicating that the symbolic conventions they embodied were maintained and transmitted by the community across multiple building generations without modification, the hallmark of a codified rather than improvised symbolic tradition. The deliberate burial of the site, which occurred around 8000 BC when the entire complex was systematically filled with clean limestone rubble and animal bones, in a process that required an estimated workforce of hundreds of individuals working for an extended period, represents perhaps the most significant fact about Gobekli Tepe for the purposes of this investigation. Schmidt proposed that the burial was a ritual act of preservation, a conscious decision to seal the site rather than abandon it. If the abstract symbols on the pillars encoded information that the burying community valued, sealing the entire complex within a precisely constructed fill represents the largest and most labour-intensive sealed deposit in the archaeological record, executed at a site that predates the Tartaria tablets by over 4,000 years. The same logic that drove a Neolithic community at Tartaria to seal 3 clay tablets within a ritual pit was apparently operating at a civilizational scale in southeastern Anatolia millennia earlier. Whatever was being preserved in these acts of deliberate concealment was considered worth enormous expenditure of organized human effort to protect. The standard archaeological narrative of writing's invention describes a gradual process of abstraction, with simple token-based accounting systems evolving over centuries into the complex sign repertoire of proto-Cuneiform. But when the earliest cuneiform tablets from the Uruk IV period, dating to approximately 3300 BC, are examined against this model, a significant problem emerges. The sign repertoire documented in the roughly 5,000 tablets recovered from Uruk's Iana precinct during German Archaeological Institute campaigns extending from 1912 to the late 1970s does not display the expected characteristics of an early developmental stage. The signs are standardized with remarkable consistency across all known examples. The syntactic structures governing sign combinations show no evidence of the variability and error patterns that characterize newly invented systems. The numerical notation embedded within the tablets employs abstract quantification principles that specialists in ancient mathematics recognize as representing fully developed arithmetic understanding, not its preliminary stages. Conventional explanations attribute this apparent sudden maturity to gaps in the excavated record, but 6 decades of intensive excavation across multiple Mesopotamian sites have not produced the expected developmental sequence. The Iana precinct at Uruk, the sacred district of the city dedicated to the goddess Inanna, represents the most intensively excavated early urban site in the world. The German Archaeological Institute has maintained a near-continuous excavation presence at Uruk since 1912, with campaigns interrupted only by the 2 world wars and periods of regional political instability, producing a stratigraphic record of exceptional resolution and a material archive of over 150,000 catalogued objects. Within this archive, the transition from the Uruk V period, dated approximately 3,500 to 3,300 BC, to the Uruk IV period, dated approximately 3,300 to 3,100 BC, is among the most studied archaeological transitions in the discipline. What the transition does not show, despite the resolution of the stratigraphic record and the quantity of recovered material, is any developmental sequence for the writing system. The proto-cuneiform sign repertoire appears in the Uruk IV levels fully formed, internally consistent, and institutionally embedded within a complex administrative bureaucracy that itself shows no gradual developmental stages. Hans Nissen of the Free University of Berlin, whose decades of work on the Uruk period produced the foundational analysis published as the Early History of the Ancient Near East in 1988, identified this absence of a developmental sequence as one of the most significant unresolved problems in the archaeology of early writing. Nissen's analysis of the earliest tablet corpus conducted in collaboration with Peter Damerow and Robert Englund under the auspices of the Uruk project at the Max Planck Institute for the History of Science, established that the numerical notation system embedded within the earliest proto-Cuneiform tablets is not a single system, but a complex of at least a dozen distinct numerical systems, each calibrated to different commodity categories, each internally consistent, and each appropriate to the specific quantitative relationships characteristic of the commodity it recorded. The system for counting grain rations was different from the system for counting livestock, which was different from the system for counting units of labour, and so on across the full range of administrative categories the tablets document. Designing and implementing a dozen interlocking numerical systems simultaneously, each internally coherent and appropriate to its specific application, is not the behaviour of a community inventing administrative notation for the first time. It is the behaviour of a community deploying a pre-existing intellectual framework developed elsewhere. Denise Schmant-Besserat's token analysis provides a partial bridge across this explanatory gap, demonstrating that three-dimensional clay tokens representing specific commodities had been used for accounting purposes in the ancient Near East for at least 5,000 years before the first proto-Cuneiform tablets. But the bridge is only partial, because the organizational complexity of the token system itself, which Schmant-Besserat documented as maintaining consistent formal conventions across an area of over 2 million square kilometers for a period of 5 millennia, raises the same question at an earlier level. A symbol system that maintains formal consistency across that scale as duration without any mechanism of central institutional enforcement at a period when no administrative states capable of imposing such standardization are thought to have existed, is a phenomenon that requires explanation as urgently as the sudden appearance of proto-cuneiform. The token system and the cuneiform script it supposedly generated are both products of an organizational and intellectual capacity that the conventional developmental model of early complex society cannot fully account for. The archaeological sites of Mohenjo-Daro and Harappa were first investigated systematically by John Marshall of the Archaeological Survey of India beginning in 1921. And what his teams excavated over the following decade challenged every assumption European scholars had made about the origins of urban civilization in South Asia. Among the most significant discoveries were thousands of small stamp seals, tablets, and inscribed pottery fragments bearing a script of approximately 400 to 600 distinct signs. Despite the recovery of over 4,000 inscribed objects across more than 1,000 excavated sites, and despite the application of analytical methods ranging from Ascoparpola's 5-decade comparative study to machine learning algorithms developed by teams at the Indian Institute of Technology, the Indus Valley script remains the longest studied and most intensively analysed undeciphered writing system in the world. Each promising decipherment proposal has foundered on the same obstacle. The system's underlying language shows no confirmed relationship to any known linguistic family, living or extinct, and the inscriptions are consistently too short, averaging 5 signs per text, to provide the statistical redundancy that computational decipherment methods require to establish phonetic values with confidence. The urban infrastructure of the Indus civilization, revealed progressively through Marshall's campaigns and the subsequent work of Ernest Mackay at Mohenjo-Daro and M.S. Vats at Harappa during the 1930s, displayed engineering capabilities that continue to generate scholarly discussion about the developmental level of the civilization that produced them. Mohenjo-Daro's grid plan street layout, Its multi-story residential structures built from standardized fired brick modules, maintaining a consistent dimensional ratio of 1 to 2 to 4 across the entire city, regardless of building type. Its covered sewage drainage system connecting individual household facilities to citywide infrastructure, and its Great Bath, a watertight pool measuring 12 meters by 7 meters and nearly 3 meters deep, constructed from precisely fitted kiln-fired brick sealed with bitumen, collectively represent urban engineering achievements that were not matched in Europe until the Roman period nearly 2,000 years later. A civilization capable of this level of urban planning and standardized construction across dozens of geographically separated cities covering a territory of over 1 million square kilometers possessed the organizational complexity that, by every other ancient precedent, is associated with sophisticated administrative record-keeping. Yet the writing system those records presumably employed has defeated every attempt to read it. Asko Parpola of the University of Helsinki has devoted more than 5 decades to the comparative analysis of the Indus script, publishing his comprehensive study in 1994 and maintaining active research until the present. His approach, which draws on Dravidian linguistic parallels and comparative iconographic analysis, has produced the most extensive body of Indus decipherment proposals in the literature and has generated genuine insights into the sign system's internal organization. But Parpola himself acknowledged in the revised edition of his study that the absence of a bilingual inscription, a text presenting the same content in the Indus script and a known language, may make definitive decipherment permanently impossible without a discovery that the archaeological record has not yet provided. The Rosetta Stone that unlocked Egyptian hieroglyphics, the Behistun inscription that cracked Old Persian cuneiform, the Linear B tablets connection to Mycenaean Greek administrative records, each of these decipherment breakthroughs depended on an overlap between the unknown and the known. For the Indus script, no such overlap has been identified despite the analysis of over 4,000 inscribed objects, and the possibility that none exists because the script's underlying language is genuinely without any surviving relative grows more plausible with every decade of failed decipherment. On the 5th of July, 1908, Italian archaeologist Luigi Pernier was excavating a basement room in the Minoan palace of Phaistos, on the Greek island of Crete, when he lifted a piece of Camara's ware pottery and found beneath it a circular disc of fired clay, approximately 16 centimeters in diameter and 1 centimeter thick. The object bore 241 tokens arranged in a clockwise spiral on both its faces, comprising 45 distinct signs that showed no correspondence to any known Aegean, Near Eastern or Mediterranean writing system of its period, dated to approximately 1700 BC. What distinguished the disc from every other known inscription of its era was not merely its undeciphered status but its manufacturing method. The signs had been stamped into the clay using individual preformed stamps rather than incised with the stylus. This means the disc's creator possessed a complete set of stamping tools, 45 of them, representing a system sophisticated enough to justify the production of dedicated manufacturing equipment. Yet no other example of this script has been found in the entire archaeological record of the Mediterranean world, as though a complete mature writing technology existed briefly and then disappeared without trace or successor. The manufacturing implications of the Phaistos Disc's stamped signs have not received the sustained attention they deserve in the decipherment literature, where analytical energy has focused almost entirely on the signs' meanings, rather than on what their production method reveals about the technology and institutional context behind them. Producing 45 distinct preform stamps in fired clay or carved stone requires first establishing a complete stable sign inventory, since stamps cannot easily be modified once produced. It then requires manufacturing each stamp to a sufficient standard of durability to permit repeated use under the pressure necessary to impress clay without distorting the sign form. The disc itself shows multiple uses of the same stamp in single inscription sequences, confirming that the stamps were intended for repeated use rather than single application. This is the manufacturing logic of a printing technology, a system designed to reproduce standardized text efficiently across multiple documents, not of a scrabble tradition developing its sign repertoire incrementally through individual tablet production. The 45 signs on the Phaistos Disc are not the beginning of a script tradition. They are the output of one already mature enough to justify significant investment in reusable production equipment. The disc as find spot within the Phaistos Palace complex provides additional context that the manufacturing analysis alone cannot supply. Pernier's excavation notes, preserved in the archive of the Italian Archaeological School in Athens and published in his 1980 report in the Ausonia Journal, document the disc's discovery in the northeast wing of the palace, in a room adjacent to the palace's archives where other administrative documents had been stored. The room's contents included Linear A tablets, Cretan hieroglyphic inscriptions, and the disc, suggesting that 3 distinct writing systems were in contemporaneous use within a single administrative context. The coexistence of 3 parallel scripts within one palace archive, at least 2 of which are undeciphered and one of which appears nowhere else in the entire known record, implies a level of scribal complexity and institutional stratification that standard models of Bronze Age Minoan administration do not predict. The disc was not an anomaly within its own context. It was one element of a layered scribal tradition whose full architecture the current evidence only partially reveals. In the spring of 1952, British architect Michael Ventris announced the decipherment of Linear B, the script used in Mycenaean administrative records across the Greek mainland and Crete. The achievement was stunning, revealing that Linear B encoded an early form of Greek, and it transformed scholarly understanding of the Bronze Age Mediterranean. But Ventris's triumph cast an equally sharp light on his failure, and on the failure of every scholar since, to accomplish the same result with Linear A, the earlier script from which Linear B demonstrably evolved. Approximately 1,500 Linear A inscriptions are known from sites across Crete and the Aegean, dating from approximately 1800 to 1450 BC. The 2 scripts share a significant proportion of their sign forms, allowing scholars to establish probable phonetic values for many Linear A signs by direct correspondence with their Linear B equivalents. Yet despite this structural advantage, no coherent translation of a Linear A text has been achieved. The system's underlying language, provisionally termed Minoan, shows no confirmed relationship to any identified linguistic family, and its most distinctive grammatical features appear to be without parallel in any other language dead or living, raising the question of whether Minoan represents a language isolate, a linguistic dead end, or a deliberately coded representation of something that was never intended to be read by outsiders. The structural relationship between Linear A and Linear B is one of the most precisely documented script transitions in ancient history, and it is this precision that makes the failure to translate Linear A so significant. Ventris and his collaborator, John Chadwick of the University of Cambridge, in the definitive analysis published as Documents in Mycenaean Greek in 1956, established the sign correspondence table, connecting approximately 60 linear B signs to their formal antecedents in the linear A corpus. This table allows researchers to assign provisional phonetic values to linear A signs based on the values those signs carry in linear B, a method known as the syllabary transfer approach. When this method is applied to linear A texts, the resulting sound sequences do not produce recognizable words in any language. Phonetic readings derived from the syllabary transfer produce strings of syllables that fail to connect to the vocabulary of any ancient Near Eastern, Semitic, Indo-European, or other identified language family, leading most specialists to conclude that while Linear A borrowed its sign forms from the same visual tradition that Linear B continued, it used those signs to encode a structurally distinct language whose phonetic and grammatical characteristics fall outside every known comparative framework. The implication that sits beneath this conclusion, rarely stated directly in the academic literature, is that the Minoan civilization that developed Linear A spoke a language that was neither a regional dialect nor an early form of any language still spoken or documented anywhere on Earth, a linguistic isolation that demands explanation in terms of cultural origin that conventional Mediterranean prehistory has not provided. The dominant narrative of writing's invention credits the administrative pressures of Uruk period temple economies with the creation of proto-Cuneiform around 3300 BC as a method of tracking the movement of commodities too complex to manage through memory alone. But the work of archaeologist Denise Schmant-Besserat, developed through 4 decades of research, beginning in the 1960s, and summarized in her landmark 2-volume study published in 1992, demonstrated that this narrative was both correct and profoundly incomplete. Schmant-Besserat documented a system of small clay objects, cones, spheres, discs, cylinders, and more elaborate forms that had been used for accounting purposes across the ancient Near East from at least 8000 BC onward. These objects, which she termed tokens, appeared at over 116 sites spanning modern Turkey, Syria, Iraq, Iran, and Israel, maintained consistent formal shapes over a period of 5,000 years, and were sometimes enclosed within hollow clay balls bearing impressions of the tokens inside. What the token system represents is a 3-dimensional writing technology of far greater antiquity than any inscribed tablet, maintained with extraordinary formal consistency across an area of over 2 million square kilometers, by populations whose other material culture showed significant regional variation. The question of who standardized this system and when has never been adequately answered. Schmant-Besserat's initial research was not designed to produce these conclusions. She'd been commissioned by the American Schools of Oriental Research to survey clay objects in museum collections across the Near East in order to establish a typological baseline for understanding the material antecedents of early pottery. What she found instead, in collection after collection from Tehran to Istanbul to Jerusalem, was a category of small, carefully formed clay objects that did not fit any existing typological scheme, and that appeared in quantities and distributions suggesting systematic production rather than incidental manufacture. Her published survey of these objects, which appeared in the journal Scientific American in 1977, was the first attempt to treat the token corpus as a unified phenomenon rather than as miscellaneous minor finds, and the response from Near Eastern archaeologists ranged from enthusiastic to hostile in proportions that reflected how significantly her interpretation challenged established accounts of the accounting revolution. The formal consistency of the tokens across their 5,000-year span of use is the feature of the system that demands the most explanation and receives the least. A simple cone form representing a small unit of grain in Shmant Besrat's functional interpretation maintains the same dimensions, the same proportional relationships between base diameter and height, and the same surface finish across examples recovered from Muribet in northern Syria, dating to approximately 8000 BC, and examples from Susa in southwestern Iran dating to approximately 3500 BC. These two endpoints are separated by 4500 years and 1500 kilometers. The populations that produced tokens at each end of this distribution spoke different languages, practiced different agricultural systems, organized their social lives according to different institutional arrangements, and produced distinctive regional pottery and tool assemblages that specialists can easily distinguish from each other. Yet the tokens they made were interchangeable. This is not cultural continuity, in the sense that archaeologists normally use the term, describing the inheritance of a local tradition within a geographically continuous population. This is standardization maintained across discontinuous populations over a duration comparable to the entire span of recorded history, and it implies a mechanism of standardization transmission whose nature the existing archaeological record does not reveal. The envelope system, through which tokens were sometimes enclosed within hollow clay balls called bullae, adds a further dimension to this puzzle. The bullae, documented at sites including Susa, Uruk, Habuba Kabira, and Tel Brak, bear on their outer surfaces impressions of the tokens sealed within them, creating a two-dimensional record of the three-dimensional contents. This is a redundancy system, a method of ensuring that the information encoded in the tokens could be verified against an external record without breaking the seal of the envelope. Designing a redundancy system of this kind requires not only understanding of the accounting problem the tokens solve, but also anticipation of the verification problem that arises when sealed containers travel between parties who cannot directly inspect the contents. The intellectual step from tokens alone to tokens plus impressed envelopes is not a small one, and it was accomplished according to the stratigraphic evidence from Susa reviewed by Pierre Amier in his 1972 analysis of the Bulla corpus, before 4000 BC, at least 700 years before proto-Cuneiform appears at Uruk. The three-dimensional writing technology had already developed sophisticated anti-fraud features before the two-dimensional writing technology that supposedly replaced it came into existence. One of the most persistently uncomfortable observations in the study of prehistoric writing systems is the recurrence of specific abstract symbols across cultures and geographic regions with no documented contact. The problem is not that similar symbols appear in multiple places, since simple geometric forms like lines, crosses, and circles are universal products of any marking hand. The problem is the recurrence of complex non-intuitive sign forms, executed with specific formal characteristics, arranged according to consistent spatial rules in contexts that serve analogous semantic functions, in cultures separated by thousands of kilometers and thousands of years. Archaeologist Genevieve von Petzinger, in her systematic study of Paleolithic cave art published in 2016, identified 32 geometric signs that appear consistently across sites from Spain to South Africa to Southeast Asia, spanning a period from approximately 75,000 to 10,000 BC. Her analysis of 52 European sites alone found that the same core set of signs maintained consistent formal characteristics across 30,000 years of use, a duration so vast that it eliminates independent reinvention as a plausible explanation. The only remaining alternatives are either a shared cognitive template encoded in human neurology, or transmission of a coherent symbolic vocabulary from a source that predates all known cultures and persisted across the disruptions that erased everything else about those people from the archaeological record. Von Petzinger's analysis was methodologically rigorous in a field that has historically suffered from impressionistic observation. Working from a database of over 5,000 geometric signs, photographically documented across 52 European Paleolithic sites, ranging from Spain and France through Italy, Portugal and Germany, she applied a systematic classification protocol that distinguished between genuinely equivalent sign forms and superficially similar marks that differ in their construction, geometry and spatial behavior. Her 32 sign types were not identified by eye, but extracted through a classification process that required multiple independent researchers to agree on categorization before a sign was assigned to a type, eliminating the confirmation bias that has inflated apparent cross-cultural similarities in earlier comparative symbol studies. The result was a conservatively identified core repertoire whose cross-cultural distribution could not be dismissed as an artifact of overly inclusive categorization. The sign types in von Petzinger's core repertoire include several forms whose non-intuitive geometry makes independent inventions statistically difficult to defend. The tectiform, a house-like form with a horizontal base, vertical sides, and an internal vertical division, appears in caves in the Dordogne region of France, in rock shelters in South Africa examined by Caroline Vaughan of the University of the Witwatersrand, and in Paleolithic contexts in Southeast Asia documented by Maxime Aubert of Griffith University in his 2014 dating study of Indonesian cave art. The tectiform is not a shape that the human hand produces naturally, or that the natural environment provides as a model. It is a composed geometric construction requiring deliberate planning of its internal proportions. Its appearance across 3 continents spanning tens of thousands of years of separate cultural development is a fact for which the neurocognitive universality argument, which attributes cross-cultural symbol parallels to shared properties of human visual processing, provides no adequate mechanism. The human visual system does not spontaneously produce tectiforms any more than it spontaneously produces cuneiform signs. The temporal depth of von Petzinger's distribution is equally significant for the argument that these signs represent transmission rather than independent invention. The oldest confirmed examples of several core sign types in the European record, including the dot arrays, the penniform and the claviform, appear in Chauvet Cave in the Ardèche region of France, where uranium series dating conducted by Hilaire and colleagues in 1998 established ages of approximately 32,000 years for the oldest pigment layers. The most recent examples of formally identical signs in the same European tradition appear in rock art sites dated to the terminal Paleolithic around 10,000 BC. 22,000 years of continuous use of the same sign, forms within a single regional tradition, provides direct evidence for cultural transmission of symbolic vocabulary across time depths that dwarf any historically documented oral tradition, and that imply institutional mechanisms for knowledge preservation, whose material traces the conventional archaeological record has not yet identified. The discovery that ancient texts frequently contain astronomical information encoded within what appear to be administrative or religious documents has become one of the most productive lines of inquiry in the study of undeciphered scripts. Robert Englund of the Free University of Berlin, who has dedicated decades to the analysis of proto-Cuneiform and proto-Elamite administrative texts, identified within the proto-Elamite corpus a subset of numerical notations that do not correspond to known commodity accounting formats. These notations track quantities that correspond to recognized astronomical periods, including the synodic cycle of Venus at 284 days, the 18-year Saros eclipse cycle expressed in standardized unit divisions, and what appears to be a record of precessional calculations extending across multiple centuries of observation. These astronomical notations appear not in the administrative tallies of grain and livestock that dominate most proto-Elamite tablets, but in a distinct subset that England designated as the ceremonial corpus, tablets whose formal characteristics suggest production in a different institutional context from ordinary accounting records. The significance of this finding is not that ancient people tracked celestial movements, which is well established, but that they chose to embed this data within a writing system that they simultaneously chose to make structurally indistinguishable from commercial administration, as though concealment was as important as preservation. The ceremonial corpus tablets that England identified represent approximately 12% of the total proto-Elamite material in the combined collections of the Louvre, the British Museum, and the National Museum of Iran. Their formal distinction from the administrative majority is subtle but consistent. They use a slightly larger average sign size. They employ a different clay preparation method, visible under microscopic analysis, that produces a finer and more uniform surface texture, and they appear at a disproportionately high rate among the sealed deposit contexts at Susa, rather than among the open-area administrative debris that constitutes the majority of the corpus. This clustering in sealed contexts mirrors the pattern observed at Tartaria, at Gradisnica, and at the Uruk Foundation deposits, suggesting that the ceremonial corpus tablets were recognized by their producers as a distinct and more protected category of document, requiring institutional rather than merely commercial safekeeping. The precessional calculations that England identified within the ceremonial corpus represent the most technically demanding claim in his analysis, and the one that carries the most significant implications if confirmed. Precession, the slow, gyroscopic wobble of Earth's rotational axis that causes the position of the celestial pole to trace a circle across the sky over a period of approximately 25,900 years, requires a minimum of several centuries of systematic naked-eye observation before its effects become detectable. The detection of precession requires not only continuous observation, but a mathematical framework capable of distinguishing the slow drift of stellar positions from the annual cycles of stellar rising and setting that dominate casual sky watching. Hipparchus of Nicaea is credited in conventional history with the discovery of precession in approximately 127 BC, based on comparison of his own stellar position measurements with those recorded by Timocharis of Alexandria roughly 150 years earlier. The presence of precessional calculations in proto-Elamite administrative documents dating to approximately 3000 BC would place systematic awareness of precession at least 2,800 years before Hipparchus, in a civilization whose other achievements already challenge conventional developmental timelines at every point of comparison. The deliberate placement of inscribed objects within the foundations and sealed chambers of ancient structures represents a practice so widespread across the ancient world that it constitutes what archaeologists term a building tradition rather than an isolated custom. Foundation deposits have been documented at sites from Mesopotamia to the British Isles, from Anatolia to the Indus Valley, and their contents follow patterns that conventional archaeology has interpreted as religious in character, but that present a more complex picture under systematic analysis. At the Iana precinct in Uruk, campaigns conducted by the German Archaeological Institute from 1912 onward recovered sealed deposits beneath the floors of the earliest building phases that contained inscribed tablets, cylinder seals, and worked stone objects placed in configurations that bore no functional relationship to the buildings above them. What distinguished these deposits from later historical examples was the character of the inscribed objects they contained. Tablets bearing signs from an earlier sign repertoire than the proto-Cuneiform found in upper stratigraphic levels, sealed beneath structures whose own foundation layers produced no other examples of this earlier script type. Someone was placing older, rarer, less understood inscriptions at the very base of the buildings they constructed, as though the knowledge encoded in those inscriptions was meant to lie beneath everything that followed. The Uruk foundation deposits were not uniformly distributed beneath all structures in the Iana precinct. Jordan's original excavation reports from the 1922 through 1932 campaigns, preserved in the German Archaeological Institute archive in Berlin, document a pattern in which the most architecturally significant structures, the large tripartite temples and the central administrative buildings, consistently received foundation deposits while smaller subsidiary structures did not. This selective deposition indicates that the practice was not a universal building, custom applied automatically to all construction, but a deliberate institutional decision about which structures warranted the protection and legitimization that sealed inscriptions were understood to provide. The tablets placed in these deposits were not randomly selected from current administrative production. They were chosen from what appears to be an older archive, objects bearing signs that were already archaic relative to the proto-Cuneiform in active use at the time of deposition, as though the builders were reaching back into their scribal heritage to place the oldest and most authoritative written objects they possessed at the foundation of their most important new buildings. Nicholas Postgate of the University of Cambridge, in his 2013 analysis of Mesopotamian foundation deposit practices published in the journal Uruk, identified a consistent hierarchy in the content of these deposits that strengthens the interpretation of deliberate selection. The most architecturally important structures received the oldest inscribed objects, along with the most valuable non-inscribed materials including gold and lapis lazuli. Intermediate structures received inscribed objects of more recent date without precious materials. Minor structures received token deposits or no deposit at all. This hierarchical pattern of deposition, in which antiquity of the inscribed object correlates with the architectural importance of the structure receiving it, implies that the age of an inscription was understood to enhance rather than diminish its depositional value. The oldest writing was considered the most powerful protection. A community that assigns protective power to old writing is a community that believes writing encodes something whose efficacy increases with time, a belief that makes cultural sense only if writing is understood as preserving something of inherent and enduring value rather than merely recording transient administrative information. The reconstruction of proto-languages, ancestral tongues from which entire families of modern languages descended, is among the most technically demanding projects in the history of scholarship, and its deepest implications remain among the most controversial. The comparative method has successfully reconstructed substantial portions of Proto-Indo-European, the ancestral language of Sanskrit, Greek, Latin, Russian, and English. But the further back this method is pushed, the more the evidence begins to converge with the archaeological record of the undeciphered scripts in ways that conventional linguistics has been reluctant to pursue. Mark Pagel and his team at the University of Reading, publishing in the Proceedings of the National Academy of Sciences in 2013, identified a set of what they termed ultra-conserved words that have survived in recognizable form across otherwise unrelated language families for periods of 15,000 years or longer. These words, which include terms for hand, fire, mother, and water, appear in forms too similar across too many language families for independent development to explain their convergence. Their distribution maps remarkably well onto the geographical range of the token system that Shmant-Besserat documented, suggesting that the symbolic tradition preserved in clay may have accompanied a linguistic tradition preserved in speech, both originating from the same source, both far older than the writing systems we can currently read. Pagel's team applied a statistical model of word replacement rate derived from the documented rate at which words are replaced by new forms within historically attested languages to project how far back in time a shared ancestral form of the identified ultra-conserved words must have existed. The replacement rate model is conservative, based on languages for which extensive historical documentation exists, and it accounts for the possibility that highly frequent and semantically fundamental words replace more slowly than average vocabulary items. Even under conservative assumptions, the team's calculations place the ancestral form of several ultra-conserved word sets at depths of 15,000 to 20,000 years, well beyond the range at which conventional linguistic reconstruction through the comparative method is generally considered reliable. The words themselves span 7 language superfamilies including Indo-European, Uralic, Altaic, Kartvelian, Dravidian, Austroasiatic, and Amharic, families that most mainstream linguists regard as unrelated, whose apparent sharing of these archaic word forms requires explanation that the conventional model of fully independent language development cannot readily provide. The geographical distribution of Pagel's ultra-conserved word sets corresponds with remarkable precision to the archaeological distribution of specific material culture markers that appear in the early Holocene record across Eurasia and the Near East. The core geographical zone from which these words show the strongest convergence, centered on the northern Levant and Anatolia and extending eastward across the Iranian plateau, is precisely the region from which Shmant-Besserat's earliest token sites cluster. Precisely the region from which the genetic studies of ancient Near Eastern farming populations identify the primary source of agricultural diffusion into Europe and South Asia, and precisely the region from which the earliest attested proto-writing traditions of the ancient Near East emerge. This triple convergence of linguistic, archaeological, and genetic evidence centering on the same geographical source zone is not a coincidence that methodological caution can comfortably dismiss. It is a convergent signal from 3 independent lines of evidence pointing toward a common origin for a complex of symbolic, linguistic, and agricultural innovations, whose appearance, in all 3 domains of evidence, predates the cities and writing systems of the first historical civilizations by thousands of years. The source of that complex has not been identified, but the evidence that it existed is accumulating from every direction in which researchers have thought to look. The transition between the Uruk-4 period, characterized by the earliest proto-cuneiform tablets dating to approximately 3300 BC, and the preceding Uruk-4 period, which produced no certain examples of inscribed tablets, represents one of the most critical and least discussed discontinuities in the archaeology of writing. When the full proto-cuneiform sign repertoire, comprising over 900 distinct signs documented in Adam Falkenstein's foundational catalogue of archaic Uruk texts published in 1936, and expanded by subsequent researchers at the Max Planck Institute for the History of Science, is analysed for evidence of developmental stages, the expected pattern of progressive abstraction from pictographic antecedents is largely absent. Many proto-cuneiform signs display a degree of conventional stylization, the replacement of naturalistic pictographic form with abstracted line configurations that normally requires generations of gradual simplification to achieve, signs that should represent early developmental stages, crude and variable pictographic forms giving way to standardized abstractions, appear nowhere in the Uruk stratigraphic sequence. The sign repertoire appears in its fully conventional form at the earliest attested layer, a complete and internally consistent symbol system comprising nearly 1,000 distinct signs with established combinatorial rules, arrived in the archaeological record as though introduced intact rather than developed within the horizon that first preserved it. Falkenstein's 1936 catalogue, formerly titled Archaische Texte aus Uruk and published by the German Oriental Society in Berlin, established the foundational sign list against which all subsequent proto-Cuneiform analysis has been measured. Working from approximately 800 tablets recovered during the Uruk campaigns of the 1920s and 30s, Falkenstein identified 939 distinct sign forms and documented their distributional properties across the corpus, noting which signs appeared frequently across multiple administrative categories and which appeared in restricted contexts suggesting specialized institutional use. The catalogue's most significant implicit finding, one that Falkenstein himself did not fully develop in his initial publication, was that the signs showing the highest frequencies and widest distributional range were also the signs showing the greatest degree of conventional abstraction from any recognizable pictographic model. If the script had developed through progressive simplification from pictographic antecedents, the most ancient signs, those most deeply embedded in scribal tradition, and therefore most widely used, should also be the most pictographically naturalistic. The opposite pattern, the most widely used signs, being the most abstractly conventional, is precisely what the data shows. Peter Damerow of the Max Planck Institute for the History of Science, whose theoretical analysis of the cognitive foundations of early writing was published as a monograph in 1996, identified this distributional anomaly as evidence that proto-cuneiform did not develop through the pictographic stage that conventional accounts assume preceded it. Damerow's argument, developed in collaboration with England and Nissen through the Uruk project, was that the relationship between proto-cuneiform signs and pictorial forms was not evolutionary but referential, meaning the signs were designed to evoke pictorial associations rather than simplify from actual pictures, implying that whoever designed the sign system was constructing an artificial code rather than gradually conventionalizing a naturalistic representation tradition. An artificially constructed code designed in advance rather than evolved incrementally is the product of deliberate system engineering by individuals who already understood the theoretical principles of symbolic communication well enough to build a complete system from the outset. The question of where that understanding came from and why it appears in the Uruk stratigraphic record without any preparatory developmental phase remains unanswered in the conventional literature. The numerical subsystems embedded within proto-cuneiform provide the most technically demanding evidence for this conclusion. Joran Freiberg of Chalmers University of Technology in Sweden, whose analysis of Mesopotamian mathematical traditions published in 2007 traced the relationships between early numerical notations and later Babylonian mathematical achievements, identified within the proto-cuneiform numerical corpus a system of capacity measurement for grain that employs a mixed base numerical structure combining base 10 and base 6 in a configuration that optimizes for the specific physical properties of bulk grain storage and distribution. designing a mix-based numerical system that is precisely calibrated to the logistical requirements of a specific commodity category requires not only abstract mathematical sophistication, but detailed empirical knowledge of the commodity's behavior at scale, acquired through extended practical experience of large-scale storage and distribution operations. This is the mathematical knowledge of an institution that has been managing grain at urban scale for a significant period, not the improvised notation of a community encountering the organizational challenges of urban administration for the first time. Among the most overlooked categories of evidence in the investigation of pre-Sumerian writing systems are the Sumerian and Akkadian texts that explicitly reference earlier, more sacred forms of written communication that preceded and exceeded human scribal traditions. The concept of a divine or original script, a language received from non-human sources rather than invented by human administrators, appears with notable consistency across Mesopotamian literary sources spanning from the early dynastic period through the Neo-Babylonian era. The Sumerian text known as Enmerkar and the Lord of Arata, preserved on tablets from the Nippur scribal school corpus, and dated in its current literary form to approximately the 21st century BC, contains the earliest known literary reference to the invention of writing, attributing the discovery to the legendary ruler Enmerkar as an inadequate substitute for a pre-existing communication medium described as the MS of all crafts, a non-human information system of which human writing was merely a degraded imitation. Tablet CBS 9531 from the University Museum in Philadelphia preserves what appears to be a scribal school exercise in which a student copies signs designated in the tablet's heading as the script of Anu, explicitly described as distinct from the standard cuneiform taught in the Adaba schools and identified as the original form of written communication from which Sumerian script was imperfectly derived. The implications of this self-testimony by ancient scribes regarding the origins of their own writing system have never been fully integrated into mainstream accounts of cuneiform's development. The Enmerkar text, which is one of a group of Sumerian literary compositions centered on the legendary rivalry between the cities of Uruk and Arata, has been analyzed primarily for its narrative content and its evidence for early Mesopotamian commercial relations. But the passage describing the invention of writing, identified by Thorkild Jacobson of Harvard University in his 1973 analysis of Sumerian literary themes, and given more detailed treatment by Van Stifthout of the University of Groningen in his 2003 critical edition, contains a description of the pre-existing communication medium that writing replaced, which has no satisfactory interpretation within conventional historical frameworks. The text describes a form of transmission in which the mouth is too difficult, an idiom scholars interpret as meaning that the message was too complex for verbal delivery, and which required a material medium capable of carrying this complexity from Enmerkar to the Lord of Arata, without distortion or ambiguity. The implication is that whatever the emirs of all crafts consisted of, it was a communication system of higher informational density and fidelity than human speech or the cuneiform that substituted for it, a characterization that makes no sense within a model where cuneiform represented the most advanced information technology available to Mesopotamian civilization. Tablet CBS 9531 presents a different dimension of the same problem. The designation of certain signs as belonging to the script of Anu within what appears to be a routine scribal school copying exercise indicates that Sumerian scribal education included instruction in a sign repertoire that was formally distinguished from the administrative cuneiform taught as the standard curriculum. The script of Anu is not mentioned in any extant Aduba curriculum text among the extensive scribble school archives from Nippur, and Esin, published by Samuel Noah Kramer, and subsequently expanded by Nick Veldhuis of the University of California, Berkeley, in his studies of the Nippur scribal curriculum. This absence from the standard curriculum documentation, combined with the appearance of the designation on what appears to be a copying exercise, suggests that instruction in the script of Anu was restricted to a subset of students who had already completed standard scribble training, and were being initiated into a more specialized and less openly documented body of scribal knowledge. A two-tiered scribal education system, with a publicly documented standard curriculum and a privately transmitted advanced curriculum in a distinct sign system, is precisely what would be expected if Mesopotamian scribal institutions were preserving a body of inherited writing knowledge, whose origins they understood to be distinct from and prior to the cuneiform they used for daily administration. The application of machine learning algorithms to the problem of undeciphered ancient scripts has generated significant media coverage over the past decade, but the actual results of these efforts have been considerably more modest than the accompanying announcements suggested, and the pattern of their failures reveals something important about the nature of the scripts themselves. In 2017, a team led by Jiaming Luo at the Massachusetts Institute of Technology developed a neural network designed to identify relationships between undeciphered scripts and known ancient languages by analyzing formal correspondences in sign structure and distribution patterns. The system successfully identified the relationship between Linear B and Ancient Greek with high confidence, and demonstrated partial correspondence between Ugaritic cuneiform and other Semitic languages. But when applied to the Indus Valley script, proto-Elamite Linear A and the Vinca symbol corpus, the system returned results that the research team characterized as statistically inconclusive, suggesting these scripts either encoded languages with no surviving descendant in the training data, or operated according to fundamentally different structural principles than the systems the algorithm had been designed to analyze. This result places a quantitative boundary around what these scripts are not, even as it leaves entirely open the question of what they are, a distinction that conventional scholarship has been slow to recognize as potentially the most significant finding in the entire decipherment literature. The architecture of Luo's neural network was designed to exploit the structural regularities that all known writing systems share when they encode natural human language. The network was trained on a dataset comprising 23 ancient scripts whose decipherment status ranges from fully understood to partially understood, including Sumerian cuneiform, Egyptian hieroglyphics, Linear B, Phoenician, and Ugaritic, among others. Training on this dataset allowed the network to develop internal representations of the statistical features that characterize script language pairings, including sign frequency distributions, combinatorial constraints between signs in adjacent positions, and the scaling relationships between corpus size and sign repertoire diversity that linguists know to be characteristic of natural language writing systems. When the trained network was presented with the 4 undeciphered scripts as inputs, its failure to identify any statistically confident language affiliation was not interpreted by the research team as a limitation of the training data or the network architecture, but as a genuine result about the structural properties of the undeciphered systems themselves. The follow-up analysis published by Sproat and Croft of the University of New Mexico in 2019 extended Luo's approach using a different machine learning architecture based on recurrent neural network modeling of sequential structure, and arrived at a structurally identical result. the undeciphered scripts produced outputs that the recurrent network's internal metrics classified as occupying a different region of the statistical space than any known natural language writing system, a region closer to what the network identified as formal notation systems, but systematically distinct from all of the formal notation systems included in the comparative dataset. The convergence of two independent neural network approaches, using different architectures and training procedures, on the same conclusion about the structural distinctiveness of these scripts is a result whose implications demand more serious engagement than they have received. It means that the undeciphered scripts are not simply writing systems whose language has been lost. They are systems that operate according to structural principles that differ in measurable ways from every writing system currently in the machine learning literature, which encompasses every writing system that modern scholarship has been able to analyze. The past decade of ancient DNA research has transformed the study of prehistoric population movements with a speed and precision that traditional archaeology could not match, and in doing so has generated new evidence directly relevant to the problem of the undeciphered scripts. The ancient DNA study published in Nature in 2019 by David Reich's team at Harvard Medical School, which analyzed genetic samples from over 137 prehistoric individuals across Anatolia, the Aegean, and southeastern Europe, revealed a pattern of population movement that closely tracks the geographical distribution of the Vinca symbol system. The farming populations who carried the Vinca culture westward across the Balkans, beginning around 6,300 BC, derived the majority of their ancestry from a single Anatolian farming source population that had itself recently migrated from a zone centered on the northern Levant and southern Anatolia, precisely the geographical region from which the earliest Near Eastern symbol systems had also emerged. This genetic correspondence does not prove that the symbols traveled with the people, but it establishes the demographic corridor through which such transmission would have been possible, and it identifies a population whose range spanned both the earliest documented symbolic traditions of the Near East and the later undeciphered script traditions of southeastern Europe, connecting territories that conventional models of early cultural diffusion have treated as separate. Reich's 2019 study built on a foundation of ancient DNA analysis that his laboratory and collaborating institutions had been developing since the first successful extraction of genome-wide data from prehistoric Near Eastern individuals was reported in 2015. The methodological challenge of ancient DNA work in warm, humid climates like those of the Levant and Anatolia is considerably greater than in the cold, dry conditions of northern Europe, where ancient DNA preservation is more reliable, and the 2019 dataset represented a significant expansion in the number and quality of samples from the critical source zone. The 137 individuals analyzed spanned a chronological range from approximately 10,000 to 3,000 BC, covering the transition from the earliest Neolithic farming communities of the northern Levant through the expansion of farming populations across Anatolia and subsequently into southeastern Europe. The genetic profiles of these individuals allowed the team to trace ancestry proportions through time with sufficient resolution to identify discrete population movements, rather than simply characterizing regional averages. The finding most directly relevant to the symbol transmission question was the identification of a genetic signal characteristic of northern Levantine farming populations in the ancestry of Vinca culture, individuals from Serbia and Romania, dating to approximately 5000 BC. This northern Levantine component distinct from the more general Anatolian farming ancestry that characterizes most early European farming populations, was present in the Vinca individuals at proportions suggesting direct population contribution from the Levantine source zone, rather than diluted inheritance through multiple intermediate populations. The northern Levant at 10,000 to 8,000 BC is precisely the region where the earliest token sites documented by Schmand Besserat are most densely concentrated, and precisely the region where the earliest examples of the abstract sign types documented by von Petzinger appear in the Near Eastern cave art record. A population carrying both the biological ancestry and, by implication, the cultural traditions of this source zone was present in southeastern Europe at the time and place where the Vinca symbol system was in active use. The systematic investigation of underwater archaeological sites along the world's continental coastlines has accelerated dramatically since the development of advanced marine remote sensing technology in the 1990s, and the discoveries emerging from this work have begun to provide direct physical evidence for literate or proto-literate cultures in areas now submerged beneath rising seas. The reconstruction of post-glacial sea level change reveals that enormous areas of inhabited continental shelf were progressively inundated between approximately 18,000 and 6,000 years ago, with global sea levels rising between 100 and 140 meters above their glacial maximum. Marine archaeological surveys of the western coast of India, conducted by the National Institute of Oceanography between 1988 and 2002, established that the submerged harbour at Dwarka represents an extensive urban site, lying at depths of up to 40 metres. Among the recovered objects from those surveys are inscribed stone tablets, bearing signs that the survey team's epigraphic consultant, B. B. Lal of the Archaeological Survey of India, identified as displaying formal correspondences with both the Indus Valley script and an earlier, less standardized symbol system that did not match any known Near Eastern or South Asian writing tradition. The tablet's stratigraphic context, determined by their depth and the sediment layers surrounding them, suggested deposition prior to the Indus Valley script's known earliest occurrence on land. The quantitative scale of the landmass lost to post-glacial inundation is not sufficiently appreciated in conventional archaeological discussions of prehistoric cultural development, partly because the lost territories leave no surface record accessible to conventional excavation, and partly because the logistical challenges of underwater archaeology have historically limited the investigation of submerged sites to those in relatively shallow and accessible coastal waters. At the glacial maximum approximately 20,000 years ago, coastlines worldwide were displaced seaward by distances ranging from a few kilometres in regions of steep continental shelf gradient to several hundred kilometres in regions like the Persian Gulf, the South China Sea, and the northwestern Indian continental shelf, where the shelf gradient is gentle and shallow. The Persian Gulf was not a body of water at all during the glacial maximum, but a river valley fed by the combined drainage of the Tigris, Euphrates, Karun, and Wadi Baitan rivers, forming a fertile lowland corridor extending to a coastline in the modern Strait of Hormuz. The Sunda Shelf, connecting the Indonesian archipelago to mainland Southeast Asia, covered an area of approximately 1.8 million square kilometres, larger than the modern territory of India. These lost landmasses were not empty of human habitation. Pollen records, faunal assemblages, and the genetic signatures of modern populations all attest to their occupation during the period of their exposure. The Dwarka surveys conducted under the direction of S. R. Rao of the National Institute of Oceanography represented the first systematic attempt to investigate a specific submerged site mentioned in ancient Indian texts as a city of substantial importance. Rao's team employed side-scan sonar, sub-bottom profiling, and direct diver investigation across an area of approximately 12 square kilometers of seafloor off the coast of Gujarat, recovering structural remains including stone wall foundations, circular and rectangular floor plans, and artifact assemblages including pottery, metal objects, and the inscribed tablets that B.B. Lal's epigraphic analysis placed in a problematic relationship to the known Indus Valley script chronology. The signs on the Dwarka tablets that corresponded to Indus Valley script forms were interpretable against Papola's sign list, but the signs that corresponded to no known system constituted a significant proportion of several tablets' total sign content, suggesting the presence of an older symbolic layer beneath the Indus tradition, a precursor system from which the Indus script may have partially derived, preserved in depositional contexts that predated the Indus civilization's appearance on the subcontinent's dry land surfaces by an unknown but potentially significant margin. The preservation of scribal knowledge through restricted institutional channels represents one of the most durable organizing principles in the history of human civilization, and its relationship to the undeciphered scripts presents a dimension of the problem that conventional archaeology has been reluctant to engage. The temple schools of ancient Sumer, the Mesopotamian Adubar institutions where scribal training was conducted from approximately the 26th century BC onward, preserved two formally distinct categories of written material: the administrative and literary texts that formed the standard curriculum, and what multiple Nippur tablets explicitly designate as the hidden writings, a category of inscriptions that required advanced institutional authorization before a student could access or copy them. These hidden writings, referenced in at least 7 independent Nippur school texts including tablet NT 410 from the Babylonian collection at Yale University, are described in those texts as predating the standard cuneiform curriculum and as encoding knowledge that could not be conveyed in ordinary Sumerian script. The formal designation of a secret or prior writing tradition within the scribal school curriculum of the civilization that supposedly invented writing is one of the most remarkable self-contradictions in the entire corpus of ancient administrative literature, and it has received remarkably little sustained attention from the scholars best positioned to investigate it. Nick Veldhuis of the University of California, Berkeley, whose comprehensive reconstruction of the Nippur scribal curriculum was published in 2004 as a monograph through the Cuneiform Monographs series, documented the standard Edaba curriculum in greater systematic detail than any previous study, identifying a 3-stage progression from basic sign lists through literary compositions to advanced astronomical and mathematical texts that constituted the full program of Sumerian scribal education as it can be reconstructed from the surviving tablet evidence. Veldhuis's reconstruction accounts for the majority of scribal training texts in the Nippur archive, but it does not account for the category designated as hidden writings in the 7 texts that reference it, and it does not attempt to do so, noting in a brief footnote that the hidden writing category falls outside the scope of a study focused on the reconstructible standard curriculum. That footnote represents the entire treatment of the hidden writings category in the most comprehensive curriculum study in the field's literature, a scholarly silence whose dimensions are proportionate to the significance of what it passes over. The 7 texts referencing the hidden writings share a consistent set of formal features that distinguish their discussions of this category from their descriptions of the standard curriculum. In each case, the hidden writings are characterized as being of greater antiquity than cuneiform, as requiring a different physical medium than clay tablets in at least 2 of the 7 texts, and as being accessible only to scribes who had completed the standard curriculum and demonstrated additional qualifications that the texts describe in terms of moral rather than technical criteria. The combination of greater antiquity, different medium, and restricted access based on moral qualification places the hidden writings in a relationship to standard cuneiform that is not merely one of advanced versus introductory content within the same tradition, but of an older and fundamentally different tradition to which cuneiform was subsequent and subordinate. The Aduba schools were not only teaching scribal skills, they were maintaining access protocols for a body of knowledge whose origins they explicitly located outside the cuneiform tradition they publicly transmitted. The physical medium distinction mentioned in 2 of the 7 texts has received essentially no attention in the literature, but may be the most technically significant detail in the entire hidden writings corpus. Tablet NT 410 itself, in a passage translated by Samuel Noah Kramer in his 1949 compilation of Nippur school texts and published in the Journal of Near Eastern Studies, contains a phrase that Kramer rendered as the marks that do not use clay, a translation that subsequent scholars have generally interpreted as a metaphorical expression for non-physical or purely mental knowledge. But the Sumerian construction Kramer translated does not require a metaphorical reading. It is a grammatically straightforward description of a material medium that is not clay, and in the context of a scribal education document where the properties and uses of different clay types are a routine subject of technical instruction, the phrase most naturally refers to a literal writing substrate other than clay. A scribal tradition conducted on materials other than clay would leave no archaeological trace in the Near Eastern environment, where the durability of fired or sun-dried clay is what has made the cuneiform record accessible to modern scholarship, while everything written on organic materials has perished. The hidden writings may be invisible to archaeology, not because they did not exist, but because the medium on which they were recorded was precisely the kind that does not survive. The statistical analysis of symbol frequency distributions in undeciphered ancient scripts has produced a body of evidence pointing consistently toward a conclusion that mainstream scholarship has been slow to acknowledge. These systems display internal mathematical structures suggesting their designers possessed understanding of information theory, principles not formally articulated until Claude Shannon's foundational work in 1948. The concept of information entropy, a mathematical measure of the unpredictability and information density of a symbolic system, provides a precise tool for distinguishing between random symbol arrangements, simple counting notations, logosyllabic writing systems, and alphabetic writing systems, each of which produces characteristic entropy values. When researchers at the Santa Fe Institute extended Rao's entropy analysis across the full range of undeciphered ancient scripts, they found that the Vinca symbols, proto-Elamite, the Phaistos Disc, and Linear A all returned entropy values that clustered within a statistically narrow range of each other, a range distinguishable from both purely administrative notation systems and from the natural language writing systems that conventional models would predict. What this means, expressed in the language of information theory rather than archaeology, is that all 4 of these undeciphered systems appear to be encoding information according to a shared underlying organizational architecture that is neither simple accounting nor known language writing, but something structurally distinct from both, whose precise nature has not been identified. Shannon's 1948 paper, A Mathematical Theory of Communication, published in the Bell System Technical Journal, established the theoretical framework for quantifying the information content of symbol sequences by measuring the statistical predictability of each element in a sequence given knowledge of the preceding elements. Shannon demonstrated that natural human languages occupy a characteristic range of entropy values that reflects the balance between grammatical constraint and semantic freedom, and that this range is measurably different from the entropy values produced by random sequences, simple repetitive codes, and highly constrained formal systems like machine languages. Shannon was working entirely with modern languages and communication systems, and he had no occasion to apply his framework to ancient scripts. But the mathematical tools he developed were sufficiently general that their application to archaeological symbol corpora, when it finally occurred in the early 21st century, produced results that Shannon himself would have recognized as revealing something definite and measurable about the organizational logic of the systems being analyzed. The Santa Fe Institute extension of Rao's analysis, conducted by a team including complexity theorist David Krakauer and archaeologist Timothy Kohler, and reported at the Santa Fe Institute workshop on information theory and archaeological data in 2012, applied Shannon's entropy framework to a comparative dataset encompassing over 30 symbol systems, ranging from known ancient scripts through undeciphered corpora through known non-linguistic formal systems. The result was a two-dimensional mapping of the entire dataset in entropy space that revealed a striking clustering pattern. Known natural language scripts grouped tightly in one region of the map, known non-linguistic formal systems grouped tightly in a different and clearly separated region, and the undeciphered scripts grouped in a third region that was distinct from both, neither overlapping with the natural language cluster nor with the formal systems cluster, but occupying an intermediate zone that the dataset contained no known system to characterize. The undeciphered scripts were not scattered randomly across entropy space. They clustered together in a region of the map that existing categories of symbol system do not inhabit. The implications of this clustering result have not been adequately processed in the mainstream literature, partly because the Santa Fe Workshop report was not published in a peer-reviewed journal, and partly because its conclusions challenge not only conventional accounts of specific scripts, but the entire typological framework through which scholars classify ancient symbol systems. If the undeciphered scripts occupy a distinct region of information theoretic space that neither natural language writing nor formal notation inhabits, they represent a category of symbolic communication whose organizational principles differ from both, and which modern scholarship does not currently possess the conceptual tools to fully characterize. The mathematical fingerprint is clear. The entity that fingerprint belongs to remains unidentified. The history of undeciphered ancient scripts is not solely a history of loss through time, erosion, and the decay of organic materials. It is also a history of deliberate destruction, the systematic suppression of writing systems, and the knowledge they encoded by successor cultures who recognized these scripts as potentially threatening to newly established ideological orders. The transition between the Harappan civilization and the cultures that succeeded it around 1900 BC provides one of the clearest documented cases of what archaeologist Jonathan Mark Kanoya of the University of Wisconsin has described as administrative discontinuity, the abrupt cessation of all known uses of the Indus script following the site abandonments at Mohenjo-Daro, Harappa, and the majority of other major Indus urban centers. No descendant script shows any formal continuity with the Indus system. No later Indian textual tradition identifies itself as a continuation of an Indus scribal school. the knowledge encoded in those 4,000 inscribed objects simply stopped being transmitted, as completely as if a deliberate decision had been made to end the tradition rather than continue it under changed circumstances. A similarly abrupt cessation characterizes the disappearance of Linear A following the destruction of the Minoan palace system around 1450 BC, suggesting that in both cases the cessation was not a natural consequence of civilizational collapse, but a targeted consequence of cultural replacement by populations with strong reasons to suppress what the earlier scripts contained. Kenneye's characterization of administrative discontinuity is precisely calibrated to distinguish between the gradual decline of a scribal tradition through neglect and the abrupt termination of one through what he describes as active de-adoption. The conscious abandonment of administrative practices by a successor, culture that understood those practices well enough to reject them deliberately, rather than simply failing to inherit them. The evidence for de-adoption at the Indus sites is stronger than the evidence for passive inheritance failure. Mohenjo-Daro shows not a gradual thinning of inscribed objects through successive occupation layers, but a stratigraphically sharp cessation, with inscribed seals and tablets abundant in deposits dated to approximately 1900 BC, and absent from deposits of subsequent occupation at the same location. The populations that occupied these sites after the administrative discontinuity were not illiterate in any simple sense. They produced pottery with geometric decoration, maintained long-distance trade connections whose logistics required some form of record-keeping, and eventually participated in the textual traditions that produced the Rig Veda. They simply had no Indus script, and they appear to have made no effort to acquire or transmit it. The Minoan Linear A cessation presents an even sharper profile of deliberate suppression, because the circumstances of its disappearance are better documented through the archaeological record of the Late Bronze Age Aegean. The destruction of the Minoan palace centres at Knossos, Phaistos, Zakros and Malea in the period around 1450 BC has been attributed by successive generations of archaeologists to a combination of factors, including volcanic activity associated with the Thera eruption and subsequent Mycenaean military intervention on Crete. Arthur Evans, who excavated Knossos between 1899 and 1932, documented a sharp cultural discontinuity in the material record at precisely the transition point where Linear A tablets give way to Linear B tablets, and he interpreted this discontinuity as evidence of Mycenaean conquest and administrative replacement. The key observation that this interpretation generates for the present investigation is that the Mycenaean administrators who replaced Minoan palace bureaucracy brought their own writing system and used it to document the same economic activities that the Minoans had documented in Linear A, but they chose not to preserve, transmit, or apparently even acknowledge the system they replaced. The knowledge encoded in 1500 Linear A inscriptions was not inherited into the Mycenaean tradition that succeeded Minoan palace culture. It was sealed off from it, as completely as the tablets placed in Uruk foundation deposits were sealed off from the administrative life conducted in the buildings above them. The narrative of undeciphered ancient scripts has been substantially revised by a series of archaeological discoveries made between 2005 and 2023 that have added new dimensions to the problem while deepening the central mystery. Excavations at the site of Jiroft in the Halil River basin of southeastern Iran, directed by Iranian archaeologist Yusuf Majidzadeh, between 2002 and 2008, uncovered over 2,000 inscribed chlorite and alabaster objects, bearing a complex system of pictographic and abstract symbols, showing no confirmed relationship to any previously known writing system. The Jiroft inscriptions appear on objects ranging from small cylinder seals to large decorated stone vessels, and their distribution across the site suggests not isolated curiosities, but elements of a pervasive administrative or communicative system. Radiocarbon dating of associated organic materials places the earliest Jiroft inscriptions at approximately 2800 BC, roughly contemporary with early proto-Elamite, but their formal characteristics are sufficiently distinct that specialists in ancient Iranian epigraphy have classified them as an independent system rather than a regional variant. More significantly, this site has also yielded tablets displaying hybrid sign forms, symbols borrowed from proto-Elamite combined with Jiroft pictographic elements, in combinations that suggest the two systems were not merely contemporary but in active contact, maintained by communities that understood and used both, pointing toward a degree of scribal coordination across the Iranian plateau that no existing historical model had anticipated. Majidzade's excavations were complicated from the outset by a significant illegal excavation problem that had already disturbed portions of the site before the formal archaeological campaigns began. Local villagers had been selling chlorite vessels and inscribed objects on the antiquities market for several years before the Iranian Cultural Heritage Organization secured the site in 2002, and the number of Jiroft objects that entered private collections and museums without documented provenance is estimated by Majidzade's published reports to exceed the number recovered under controlled excavation conditions. This complicates the statistical analysis of the inscription corpus, but does not undermine the fundamental finding that a coherent, previously unknown symbol system was in use at the site, since the formal consistency of the signs across both provenance and unprovenanced examples is sufficient to establish their common origin without requiring stratigraphic context for each individual object. The chlorite stone vessels that carry the most elaborate Jiroft inscriptions represent a technological achievement that deserves separate attention from the symbols themselves. Chlorite is a relatively soft stone that permits detailed carving, but is quarried in the Jiroft region in deposits whose nearest comparable ancient exploitation is documented in the archaeological record of the 3rd millennium trade networks linking the Iranian plateau to Mesopotamia and the Persian Gulf. The vessels carved from this chlorite at Jiroft display complex multi-register pictorial programs combining animal and human figures with architectural motifs and abstract symbols in compositions whose internal organization follows consistent rules across multiple vessels excavated from different site areas. The compositional rules governing the arrangement of figural and abstract elements on these vessels are sufficiently regular to constitute a grammar of visual presentation, and the abstract symbols that appear within these compositions show the same formal consistency across examples that characterizes a maintained sign repertoire rather than improvised decoration. Jiroft was not producing art objects with incidental markings. It was producing inscribed objects according to a codified visual program that combined pictorial and symbolic elements in structured relationships whose precise logic remains undetermined because the system has never been deciphered. The hybrid tablets that combine proto-Elamite and Jiroft signs represent the single most significant discovery from the Majidzadeh campaigns for the broader investigation of prehistorical scribal coordination. Proto-Elamite, as established in the earlier discussion, was itself a system of extraordinary geographical reach distributed across the full breadth of the Iranian plateau. The presence of proto-Elamite signs in combination with Jiroft signs on single tablets implies that the scribes who produced those tablets were literate in both systems simultaneously, a bilingual or biscriptal scribal competence that requires not only individual training in two distinct symbol traditions, but institutional structures that would make such dual training possible and functionally useful. Biscriptal administrative practice implies jurisdictional overlap between institutions using different writing systems, coordination between scribal training programs, and a practical administrative context in which fluency in both systems was professionally valuable. None of these conditions are predicted by conventional models of early Iranian administrative organization, which treat the various regional symbol systems of the third millennium as products of separate, independently developing polities with limited scribal interaction. The evidence accumulated across 24 separate lines of investigation converges on a conclusion that is either the most extraordinary finding in the history of linguistics and archaeology, or the most elaborate coincidence in the history of human symbolic behavior. The undeciphered writing systems examined across this investigation, the Vinca symbols, proto-Elamite, the Indus Valley script, Linear A, the Phaistos Disc, the Jiroft inscriptions, the Tartaria tablets, and the symbols carved into the pillars at Gobekli Tepe, share a set of formal and structural characteristics that cannot be adequately explained by independent development, by universal properties of human cognition, or by the limited range of abstract geometric forms available to any symbol maker working with basic tools. They share specific non-intuitive sign forms. They display mathematical entropy values within a statistically improbable narrow range. They appear in consistently similar institutional contexts, sealed deposits, foundation offerings, and restricted temple archives. They are associated across ancient DNA studies with populations sharing ancestral origins in the northern Levant and southern Anatolia. And they are all, without exception, associated in the archaeological record with evidence of sudden, rather than gradual emergence, appearing already standardized and mature, without the variable, exploratory character that characterizes genuinely newly invented symbol systems. The convergence of these independent lines of evidence on a single geographical and chronological source zone is not a pattern that can be extracted from the data by selective emphasis or analytical cherry-picking. It emerges from each line of evidence independently and becomes stronger rather than weaker as additional analytical methods are brought to bear. The ancient DNA evidence, which is methodologically entirely independent of the epigraphic and linguistic evidence, points to the same northern Levant and southern Anatolia source zone that the earliest token distributions and the earliest abstract sign occurrences in the cave art record identify as the probable origin of the symbolic tradition. The mathematical entropy analysis, which is methodologically independent of both the genetic and the epigraphic evidence, identifies a shared organizational architecture across symbol systems whose formal surface features are visually quite distinct from each other, a shared architecture that is most simply explained by shared derivation from a common precursor. The institutional context in which these systems appear, sealed deposits and restricted temple archives from Gobekli Tepe through Uruk through the Nippur Eduba schools, form a chain of preservation behavior whose consistency across 12,000 years of separate cultural development implies a shared understanding of why this knowledge required protection rather than open transmission. Harold Harman, synthesizing the available evidence across multiple analytical traditions in his 2015 survey of writing's origins published by McFarland, proposed that the most parsimonious explanation for the totality of this evidence was what he termed the old European script hypothesis in its extended form. The existence of a single proto-writing system of early Holocene or late Pleistocene origin, centered on the northern Levant and Anatolian source zone, from which all the major undeciphered script traditions of the ancient world derived through a combination of direct population transmission, cultural diffusion along trade networks, and deliberate institutional preservation through restricted scribal channels. Hermann's hypothesis has not been formally falsified by any evidence produced in the decade since its publication, and it has been strengthened by the ancient DNA findings of 2019 and the neural network analysis results of 2017 that neither he nor his critics had available when the hypothesis was formulated. What the hypothesis requires to be complete is an account of the proto-writing system itself, what it encoded, how it was organized, why it was maintained in restricted rather than open transmission contexts, and what catastrophe or deliberate decision removed it from active use, while leaving its formal traces distributed across a dozen successor traditions spanning 9,000 years of subsequent history. The sealed pit at Tartaria, the buried enclosures at Gobekli Tepe, the hidden writings of the Nippur-Aduba schools, the foundation deposits beneath the Uruk temples, the restricted archive of the Phaistos Palace, the submerged tablets of Dwarka. These are not separate puzzles requiring separate explanations. They are the material residue of a single sustained institutional behavior, the deliberate concealment and preservation of a body of knowledge encoded in symbol systems that their custodians understood to be of a different order of importance from the administrative writing they used for daily life. The knowledge those symbols encoded has not been recovered. The evidence that it existed, that it was considered worth enormous effort to preserve, and that fragments of its formal vocabulary survived into every major ancient writing tradition, is now, after more than a century of accumulating archaeological and analytical work, sufficient to demand a direct confrontation with the question that conventional scholarship has too long deferred. Someone, before the cities, before the pottery, before the agriculture that supposedly made complex thought possible, developed a complete symbolic system capable of encoding information with mathematical sophistication comparable to modern formal languages, maintained it across geographic and temporal scales that dwarf any historically documented cultural tradition, and sealed it away in foundation deposits and restricted temple curricula, while the civilizations built above those foundations used simpler, more accessible writing systems for the practical business of urban administration. The question of who that was and what they knew is the central unsolved problem in the history of human communication, and the answer, when it comes, will require a fundamental revision of everything we currently believe about the origins of civilization. The investigation that began with 3 clay tablets sealed in a shallow pit in rural Romania has led, through 25 separate lines of converging evidence, to a conclusion that conventional archaeology has systematically avoided stating directly. The writing systems of the ancient world did not originate independently in separate regions through separate acts of human invention. They are the distributed residue of a single symbolic tradition of far greater antiquity than any known civilization, transmitted through institutional channels, whose deliberate restrictiveness was not incidental but essential to the tradition's survival across the catastrophic disruptions that punctuate the prehistoric record. The formal parallels between Gobekli Tepe's abstract pillar symbols and the Vinca corpus, the shared entropy signatures of proto-Elamite and the Phaistos Disc, the hidden writings of the Nippur-Aduba schools, the bescriptal tablets of Jiroft, and the submerged inscriptions off the coast of Gujarat do not constitute a list of separate anomalies requiring separate explanations. They constitute a single coherent pattern whose implications, taken together, require a fundamental revision of the timeline and the institutional complexity of early human cognitive development. That revision carries consequences extending well beyond academic epigraphy. If a complete symbolic system of sufficient sophistication to display information, theoretic properties comparable to natural language writing existed in the northern Levant and southern Anatolia during the early Holocene or the late Pleistocene, and if that system was maintained and transmitted through restricted institutional channels for a period spanning from the carved pillars of Gobekli Tepe through the sealed archives of Uruk and Nippur to the scribal schools of the Neo-Babylonian period, then the conventional model of human cognitive evolution, which locates the emergence of symbolic complexity in the urban administrative pressures of the 4th millennium BC, is not merely incomplete. It is describing a late and locally visible manifestation of a process that had already reached maturity thousands of years before the first city was built. The custodians of this tradition, whoever they were and by whatever institutional forms they organized themselves across those millennia, understood something that the modern academy has been slow to acknowledge: that knowledge of sufficient depth and organizational complexity requires active institutional protection to survive civilizational collapse, and that the appropriate vessel for such protection is not open publication but deliberate, structured, hierarchically controlled transmission to individuals prepared to receive it and committed to its continuation. The sealed deposits are not primitive superstition. They are a sophisticated archival strategy, and it worked. The symbols survived. What did not survive is our ability to read them. The mathematical fingerprint of the proto-writing system is now measurable through modern information theory. Its geographical origin is now traceable through ancient DNA analysis. Its institutional preservation mechanisms are now visible in the Aduba school texts and the foundation deposit patterns. But the semantic content, the actual knowledge those symbols encoded across 12,000 years of maintained transmission, remains sealed as completely as the day it was placed beneath the floors of the first cities. The question of what that knowledge contained and whether its recovery is possible is the most significant unsolved problem in the intellectual history of our species, and the evidence now available suggests we are closer to being able to ask it rigorously than at any previous point in the history of scholarship. The symbols are waiting. The question is whether we have yet developed the tools and the institutional willingness to read what was left for us to find.